The Okanagan fire with the wildfires. McDougall Creek fire
due to a wildfire.
Devastating wildfires continue.
In 2023, Canada was plagued with extreme fires, with over 16.5 million hectares burned, which is about 5% of the forest in Canada. These fires caused over 104,000 people to be evacuated across Canada and led to the unfortunate deaths of 10 firefighters, with hundreds leaving with severe burns and injuries. This leaves it a crucial time for us to create something for these firefighters.
Wildland firefighters can sometimes find themselves in dangerous situations caused by the sudden advancement in the size and direction of the flame. To protect themselves in these situations, firefighters sometimes lay down heat shields to protect themselves from the raging flames. We interviewed a firefighter who spent a couple seasons working in Ontario and Alberta wildfire to hear his insight. He told us that those heat shields are not very efficient for the different terrains he worked in, especially in places like Ontario, where the ground is primarily made up of the Canadian Shield, a large area of high-grade metamorphic rock. This exposed rock often makes it impossible to pierce the ground, making these heat shields useless. While places like these do not have much loose ground, Ontario is home to over 250,000 lakes, making up about a fifth of the world's fresh water.
We identified a need for metal heat shield that would be designed specifically for use of regions with a high density of creeks, ponds, and waterways. We decided to take this approach because of the gap left in emergency safety gear available currently to firefighters in regions with terrain such as Ontario.
We wanted to ensure this design did not add much additional weight to the already heavy weight that firefighters carry with them. So we made sure our design was light and easy to use for emergencies. This is where we took inspiration from other emergency self-inflating devices such as PFDs and airplane signs. The floating shield will be small initially but will expand to protect 4 firefighters. This device is built with a heat-reflecting and resistant shield on the exterior, while having a cool, temperature-absorbing interior to absorb the coolness from the water.
The project in SolidWorks, we had to create 2 looks-like prototypes because of the limitations in SolidWorks. One being the shield fully expanded and the other being the shield compacted. This was the most efficient way for us to be able to demonstrate the device in SolidWorks.
We brainstormed various concepts to represent the heat shield, eventually coming up with the innovative idea of modeling after an arm floaty. Our first prototype involved adapting a whipped cream CO2 canister to stimulate the inflation mechanism. However, upon testing, we encountered many challenges. The surface area was insufficient, which led to excessive pressure buildup.
Regrettably, this resulted in the valve rupturing and ultimately causing the floaty to explode. This setback prompted us to reassess our design parameters and move to a bigger inflation area.
For our second prototype, we used a larger floaty to avoid the excess pressure buildup. We also covered the prototype in a heat-reflective material to more realistically model the heat shield. When creating the finalized product, we will need to increase the size and pressure of the compressed gas containers to account for the larger size of the shield. The material will need to be stronger, thicker, more heat-resistant, and more heat-reflective to prevent it from being damaged by the fire. There is also a need for a further simplified inflation mechanism to facilitate rapid deployment in emergency situations.
In conclusion, our team has recognized the need for an innovative heat shield specifically designed for wildland firefighters in regions abundant with waterways like Ontario. Through interviews with firefighters and thorough prototyping, we've devised a novel floating heat shield concept. Despite encountering setbacks during the prototyping phase, including overpressure and material durability issues, we've identified crucial areas for improvement in our design. Moving forward, we'll focus on improving container size, fortifying the shield material, and refining the inflation mechanism for efficient deployment. With further refinement, we aim to supply firefighters with a more effective, lightweight emergency safety tool tailored to their needs in hazardous wildfire scenarios.
Our initial prototype